Hi, I'm Simi, and in this lesson, we will discuss user interaction and navigation in Android applications. The user interface of your mobile app displays data on the screen and allows user to interact with it. So, in this lesson, we will talk about user interaction, how focus works, taking text input from the users, working with radio buttons, checkbox, dialogs, spinners, date pickers, time pickers, and touch gestures. It's a long list, so let's get going. Let's get started with the user interaction first. Users interact with apps by clicking buttons, long pressing the text, or to get a window pop-up, by talking like we do with Google now, and listening to music from music players. Android provides you all the input controls you need for such interactions. And to make user interactions easy, it is important to consider how your users will be using your app and what are the steps to meet user needs in the simplest way. Use UI elements in an obvious and logical workflow. To help you achieve that, always follow Android best practices when designing your app. In order to give a consistent design to your app, we need to know a little more about input controls. There are many ways to get input from the users. Like free-form, we have text and voice input, actions like buttons, menus, touch, dialogs, and choices control like date pickers, checkboxes, spinners, and many more. So here are the examples of user input controls. Here are some UI components like buttons, text views, seek bars, and so on. We will discuss them one by one later in this session. Here are more examples about UI components: alertDialog, date picker, time picker. We already knew that these UI components are simply extending the view class, and you might also remember that the view class is the basic building block for all UI components, including input control. And we make these controls interactive via XML and Java activity classes. Let's now focus on focus. It's important to remember that only one view will have focus at one time. It makes it easy for users to understand which view they are interacting with. Focus can be assigned by either tapping on a view, like a text field, or via an app-defined input flow. For example, by changing focus from one text view to another in a predefined order by you. So, how can we make component focusable? We do it by calling the method requestFocus on a specific view object. You might think, what is the difference between clickable and focusable? Well, clickable components are those which respond to being clicked, touched, or tapped. For example, the button. But focusable are the ones which gain focus to accept input. For example, an input controls such as keyboards sends input to a text field that has focus. Which view gets focused next? When we think about it, when a user interacts a mobile screen by tapping, he is always interacting with the topmost view under the touch. Another way is by doing automatically, moving the focus to the nearest neighbor component. For example, filling out a form. After submitting one input field, the focus will move to the next field automatically. So by default, the next field is defined left to right, top to bottom. It is always possible that the user is providing input using directional paths, which will shift focus based on the user interactions. For example, when interacting with Android TV, you shift the focus between buttons on the screen using directional paths on your remote. While working with focusable views, guide the user properly, like visually indicate whether is the focus now, so that users know where they are giving the input and make navigation obvious for the users. Always remember that the focusable views should be predictable and have logical order. And whenever you are designing focusable views, place them inside a view group in order from left to right and top to bottom. In a way, you want the focus to be guided between them. In XML, you have to give a view a unique ID and set it to focusable attribute to true. Then, if we want to override the default left to right and top to bottom focus order, we can specify what is the next focus, down or next focus up or next focus left or right for each of our view element in the layout. To manipulate focus using Java, you can set if a view is focusable by calling the setFocusable method on the view. You can give focus to a view by calling requestFocus on the view. You can also set an event listener for when a view gains focus by calling setOnFocusChangeListener. And lastly, remember that onFocusChange will be called on a view every time its focus gets changed. In order to find which view had focus, we can use these two methods. One of the most common ways to get input from the user is through text input. We have an edit text subclass which allows you to input values from the virtual keyboards when user tap on it. It gives you a scope to enter multiple lines with the characters, numbers, symbols, and when pressing enter or return key, it starts a new line for you. If autocorrect is also set on it, it will give you spelling suggestions as well. This input control can be customized as well. How to get text from the edit text fields? To retrieve the text, you need to get the object first by calling the familiar getObjectById, and then we'll call a getText for the object and convert it to toString, as getText method of editText returns an object of type editable but not a string. By default, text content is displayed as a plain text. By setting the input type, we can facilitate and restrict input to various types of informations like phone numbers or passwords. For example, in the last two lines, we are defining specific input in XML for a certain view. Setting the input type as phone will force the numeric keyboard to pop up when user interact with this view. Buttons. A button is a view that responds to a user click or presses. It should display text or icons over it to specify its expected behavior. A button can have a state, for example, normal, focused, disabled, pressed, on, or off, and it can contain visual attributes like raised, flat, text, and so on. We already know a click event occurs when a user taps or clicks on the button. If you remember, we have done it in an event handling session using one of two ways, either by calling onClick listener event listener in your Java code or via XML. Here is how it gets defined for the button using event listener in activity with onClick callback. In Android, we have that raised, circular, floating component, which appears to be above of the layout. They are known as floating action buttons, or FABs in short. These are usually used for the primary or promoted action for a screen. And we need to remember that there can be only one FAB per screen. For example, the Add Contact button is the primary action for the contact screen, and hence it was defined as a floating action button. In order to implement FABs, we first need to define the support library dependency in build.gradle for your app. Then we can place a FAB using this Android design widget. Here in this code, layout gravity attribute is used to define the position of the button of a layout, and image source is also provided to it. We can get an image from the app assets for the button by following these steps. Right-click on the drawable folder inside your resource folder. From there, choose action bar and tab items to represent individual action items from the drop-down menu. Now, click the clip art where Android logo is shown, and from there, pick a new icon. After this, try experimenting with the vector assets. User can provide their input from certain set of choices as well. Android gives you many choices to display your choice, like checkbox, radio buttons, toggle buttons, spinners, which are simply drop-down menus in Android. Let's discuss checkbox, radio buttons, and toggle buttons here. Checkboxes are used to let the user select one or more options from a list of options available. Typically, the list is displayed vertically, and because the user can select multiple checkboxes, so each checkbox in the list must have a separate action list now. Radio buttons. They allow the user to select one option from the list of options. As radio buttons work together, they are placed inside a radio group tag. Grouping the radio buttons also ensures that only one is selected at a time. Radio buttons are usually used with an additional submit button for the radio group. A toggle button allows only two states, either yes or no, on or off. They can have many different looks, but they are always switching between two values. Spinners. They provide you a quick way to select a value from a specific set. They give you a drop-down menu from which you can select a value. And when the list goes long, it automatically gives you a scroll view inside it. Now, how to implement a spinner? These are the steps to be followed when we are talking about implementation of a spinner. So this is the step 1. Create a spinner inside your XML. In your layout XML file, define a spinner view and provide an ID to it. Now, to define an array of spinner for the choices, we define it inside arrays.xml resource file. Here, we define it like this way, the items for our drop-down menu. Create the spinner and attach a listener to it. So, when the user selects an item from the drop-down, the spinner object receives an onItemSelect event. To define the selection event handler for a spinner, implement adapterView.onItemSelected listener interface and the corresponding onItemSelected callback method. For example, here's the implementation of this third step. Before proceeding towards further step, let's understand what is an adapter first. To insert the data into the spinner, we use adapter that pulls the content from a source such as an array or a database and fill the data into the UI component. An adapter is like a bridge or an intermediary between two incompatible interfaces. For example, a memory card reader acts as an adapter between the memory card and the laptop. Now, the fifth step, create adapter. We create adapter using an array and to the default spinner layout. This is how we initialize a new array adapter using a constructor to specify the layout for each string and the string array. So here you can see the first argument, this is the application context. Second argument, it will be the layout defined for each string in the array. Final argument in this is an array of strings which will be populated in the spinner. Now, attach this adapter to the spinner. Specify the layout for the drop-down menu by this, and here attach the adapter to the spinner by calling setAdapter method. Now, implement onItemSelected listener like this. So, it requires two methods to be override. Dialogs. A dialog is a small window that appears on the top and interrupt the user to make a decision or enter additional information. They practically require a user attention to dismiss them. alertDialog requires acknowledgement that informs the user about a situation as it occurs or notifies about an action before it occurs. For example, a confirmation dialog box before discarding a draft mail. An alertDialog can provide a title, a content area with a message and buttons that allow the user to make a decision. For example, an alertDialog might give the user a choice to agree with an action by clicking a positive button such as OK or Accept, or to disagree by clicking a negative button such as Cancel. Now, how to build the alertDialog? The following creates a dialog object and sets the title and the body message. You can add only one of each button type to an alertDialog. For example, you cannot have more than one positive button, but you can definitely set all the three types of buttons in one alertDialog. Say for example, if you wanted to have the button Yes later, and no using the set positive button, set neutral button, and set negative button on your alert dialog and naming them respectively. So here, this is how we can set a positive button. Same pattern will go for set negative button and set neutral button. Pickers. So we have date picker dialog and time picker dialogs. Use dialog fragments to show a picker. Dialog fragment is a window that floats on top of the activities window. Let's get an introduction with the fragments. A fragment is like a mini activity within an activity. That means it has a scope inside an activity only. It manages its own life cycle, receive its own input events, and can be added or removed while the parent activity is running. You can put multiple fragments in a single activity, and these fragments also have their layout which can be used in multiple activities. This is how we can implement a date picker dialog. Similarly, when we have to create a time picker dialog, we can follow these steps. Common gestures. We have touch gestures. Long touch, double tap, fling, drag, scroll, pinch. So these all are the gestures. How we can detect them? There are classes and methods available to help you handle the gestures. Gesture detector compact class for common gestures and motion event class for motion events. How we can detect all type of gestures? To detect all type of gestures, you need to perform two essential steps. Gather data about touch events, interpret the data to see if it meets the criteria of any of the gestures your app supports. A gesture starts when user touch on the screen and continues as the system tracks the position of the user's finger and ends by capturing the final event of the user's finger leaving the screen. Get the reference links and explore more for this chapter of about user input controls. And in next, we can continue the practical.